All right. So let's talk about section 1.2, which is about observational studies versus designed experiments. This is a really pretty quick little section. Oh, that should say designed, right? That should say designed right there. Designed experiments. Yeah, there will be some typos here and there in these notes, but anyway. Observational studies versus designed experiments. So what I want you to do is give the video a pause and then read through these two scenarios, okay? Um, and as you're reading through them, what I want you to do is think about, first of all, what was the goal of the study, right? So what were the researchers trying to determine? And then second of all, kind of compare and contrast the differences or compare and contrast the way that they went about trying to find an answer to that question. And then we'll talk about it together. So go ahead and give the video a pause, read through the scenarios. Okay, so I'm going to go ahead and discuss these two things, right? Assuming that you've read through them and that you've kind of given them some thought. But but what you'll notice is that in both studies, the goal of the research was to determine if radio frequencies from cell phones increased the risk of contracting brain tumors. And now the question, what's different about how the researchers determined an answer to that question? Well, in the first group, right, in the first scenario, the researchers, exposed rats to different radio frequencies to see if the rats would develop some kind of tumor. Whereas in the second scenario, the researchers didn't actually expose anyone to any radio frequencies. They just followed around a bunch of people who were, exposing themselves to radio frequencies, I guess you could say. So the way that we distinguish between these two ways to answer this question is that we call the first one a designed experiment, and we call the second one an observational study, right? So the first one was a designed experiment. And the second one was an observational study. Okay, and we'll define exactly what we mean by a designed experiment and observational study here in a second, but just kind of intuitively, right? Like a designed experiment, in scenario one, the researchers were actively manipulating things to try to see what would happen as a result of their manipulations. Whereas in scenario two, they didn't do that, right? They just watched, right? They just observed to see what would happen. So, so in order to define exactly what we mean by design experiment versus observational study, we need to define explanatory and response variables, or you may have heard them referred to as independent and dependent variables in the past. So I have some kind of crazy bird outside my window making crazy noises. Anyway, this concept will be useful for us later on in the semester as well, not just for determining if something is a designed experiment, but basically the explanatory variable is what causes something to happen, and the response variable is what happens as a result of manipulating the explanatory variable. So in other words, you can think of the explanatory variable as the cause, and you can think of the response variable as the effect. And it's not necessarily always clear which variable is causing the other one to happen. And in fact, there might not be a cause and effect relationship between the variables in a study. But oftentimes, we are interested in looking at sort of causal relationships. And at least in theory, the researcher might have an idea that they think that this particular variable is causing this other thing to happen, right? So the thing that causes, or that we think causes the other thing to happen, is called the explanatory variable, and what happens in response to that is called the response variable. So in research, we wish to determine how changing the value of an explanatory variable affects the value of a response variable. So in the previous examples, right, those first couple examples that we saw above, what is the explanatory variable and what is the response variable? So I'll let you give the video a pause and see if you can figure out what the explanatory and response variables are for those examples. Okay, so in both examples, the researchers were interested in knowing if cell phone frequencies, radio frequencies, would cause brain tumors, or just tumors in general, I suppose. But in the second scenario, it was brain tumors specifically. So so they wanted to know if radio frequency caused brain tumors. So the explanatory variable was radio frequency, and the response variable was presence of tumors, right? Brain tumors. So, so the explanatory variable was radio frequency. Radio frequency exposure, I guess we should say, right? Their exposure to these things. And the response variable was the presence of brain tumors. Okay, so that's the idea behind explanatory and response variables. Now we can define more explicitly what an observational study is versus what a designed experiment is. And so you're welcome to read through these definitions, but I'll just tell you in a nutshell, a designed experiment is one in which the researchers actively manipulate the explanatory variable to see what happens in response. Whereas in an observational study, the researcher does not actively manipulate the explanatory variable. They just observe, right? They just observe. Okay. A key factor in designed experiments is that not only do the researchers try to manipulate the explanatory variable, but they try to hold all other variables in what's the word I'm looking for? They try to control all other variables. They try to make it so that every other variable stays the same, so that the only thing that's changing is the explanatory variable. Right? That's kind of a key thing in designed experiments. Okay, but yeah, in a design experiment, they're actively manipulating the explanatory variable. In an observational study, they are not. They're just observing. Okay. So with that in mind, here are a bunch of scenarios, and let's practice determining if the scenario is an observational study or a designed experiment. I'll walk you through a couple, and then I'll let you do the rest on your own. But part A here says, a study conducted at Virginia Polytechnic Institute divided female undergraduate students into 2 groups and had the students perform as many sit-ups as possible in 90 seconds. The first group was told only to do your best, while the second group was told to try to increase the actual number of sit-ups they did each day by 10%. After 4 days, the subjects in the group that were given the vague instructions averaged 43 sit-ups, while the group that was given more specific instructions averaged 56 sit-ups in the last day's session. Okay, so this one, in this study, notice that the 2 groups, so the researchers split up the sample into 2 groups, and then they gave one of the groups one set of instructions, they gave the other group a different set of instructions. So they're actively manipulating the explanatory variable here, right? And maybe I should back up a second and just identify, right? The explanatory variable is the instructions that they were given, right? One group was told just do your best. The other group was told increase the amount of sit-ups you do each day by 10%, right? So the explanatory variable was the instructions that were given. The response variable was how many sit-ups they could perform on the last day, right? Uh, so yeah, the researchers here are actively manipulating the explanatory variable. So this is a designed experiment for sure. Designed experiment. And in fact, it might be useful for you when you're coming back to these notes to write down what the explanatory and response variables are. Right, so here the explanatory variable was instructions given, right? And the response variable was the number of sit-ups, right? Number of sit-ups they could perform on the last day. Okay, so that's part A. Let's look at part B. It says, hypertension or high blood pressure can lead to cardiovascular problems and even death. A group of 1,006 adolescents with pre-hypertension, which is moderately high blood pressure, were tracked over several years to assess which health factors led to hypertension. Okay, so this one is an observational study. Right? It's an observational study. The researchers aren't actively giving some of these adolescents health problems, right? Like it's not like they are injecting them with, I don't know, some kind of like disease or something to see if that disease causes high blood pressure to occur. No, they're just following around a group of adolescents who had moderately high blood pressure to begin with to see if they would develop full-blown high blood pressure, and if so, what health factors kind of led to that, right? But they weren't actively manipulating anything; they were just watching, right? So this is an observational study. Here, the explanatory variables are unknown. The explanatory variables are exactly what the researchers are trying to figure out. Right? So we don't know what the explanatory variables were, but the response variable was whether or not they would develop hypertension, right? Hypertension. Okay, but that one's an observational study for sure. So, so there's a couple examples. Now, I'll let you work on the rest of them on your own. So go ahead and give the video a pause. See if you can do the next 4 examples on your own, part C, D, E, and F. See if you can identify whether it's an observational study or a designed experiment. And also see if you can identify the explanatory and response variable in the study. So give the video a pause and work these out. Okay, I'm going to go ahead and give my answers. So in part C here, so it says researchers assess the effects of breathing techniques from yoga on the heart rate, systolic blood pressure, and peak expiratory flow rate. A group of 150 college students were randomly assigned to one of 2 groups. The first group received 1 hour of instruction. The second group sat quietly for an hour. Automatically, I can tell this is a designed experiment. It's a designed experiment. They're splitting the subjects up into groups and giving them different kinds of instructions, right? So they're manipulating that explanatory variable. The explanatory variable in this case would be the instructions that they received, okay? So some of them were given some yogic breathing techniques, and others were just told to sit quietly for an hour. And then the response variables, now there were actually multiple response variables that that the researchers were looking at. They were looking at the heart rate, the systolic blood pressure, and the peak expiratory flow rate. So they were looking at 3 different response variables there. So the explanatory was the instructions. And the response, well, there were 3 response variables that they were trying to measure. Trying to measure heart rate, systolic blood pressure, and peak expiratory flow rate. I don't know what that means. I'm guessing that has to do with their breathing, right? Like how much breathing how much air they're taking in and exhaling, inhaling and exhaling. Anyway, that's that. Okay, so part D. It says researchers wanted to assess the long-term psychological effects of children evacuated during World War II. They obtained a sample of 169 former evacuees and a control group of 43 people who were children during the war but were not evacuated. The subjects' mental states were evaluated using questionnaires. It was determined that the psychological well-being of individuals was adversely affected by evacuation. Okay, observational study. In order for this to be a designed experiment, the researchers would have had to have created World War II. Let's hope that they didn't create World War II just to see if being evacuated has a negative impact on your mental health, right? No, they didn't create World War II. Right? They're just observing these people who lived through the war, and they were looking at some people who were evacuated from their homes and some people who were not evacuated from their homes. And what they found out, kind of surprisingly, is that the individuals that were evacuated were adversely affected by evacuation. That's crazy because, if you're thinking, like, these are people who were living in a war zone, and it was better off for them to just stick around in their home in the war zone than to be evacuated. So that's kind of interesting. I don't know if that's actually true. You should take all of this with a grain of salt, okay? But anyway, this would be an observational study for sure. Explanatory variable here would be whether or not the person was evacuated, right? And then the response variable would be their psychological well-being. Okay, so I'm not going to write that down. You can pause the video and write that down if you want, if you haven't written it down already. Part E. Xylitol has proven effective in preventing dental cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. Overall, the children preferred the milk flavored with xylitol. They like that chemically flavor, I guess. Maybe it's sweet. Maybe it improves the taste of the milk because it makes it sweeter or something. I don't know. But they like the milk with the xylitol in it. Well, that's good because xylitol prevents dental cavities. So they can just put xylitol in milk and drinking water and prevent cavities. So that would be a good thing, I guess. But anyway, so is this a designed experiment or an observational study? This is a designed experiment for sure, right? Because the researchers are actively manipulating the explanatory variable. The explanatory variable would be presence of xylitol in the milk, right? Whether or not the milk has xylitol in it. And the response variable would be what the children preferred, right? Preference. So, and clearly you can see, right? Like the researchers gave some of the or put xylitol in some of the milk, and and then they didn't put xylitol in other milk, right? So they're actively manipulating that. So that's a designed experiment. And then part F. So a total of 974 homeless women in the Los Angeles area were surveyed to determine their level of satisfaction with the healthcare provided by shelter clinics versus healthcare provided by government clinics. The women reported greater quality satisfaction with the shelter clinics, with the shelter and outreach clinics compared to the government clinics. Okay, so this one's an observational study. And you may think, well, that's you may be a little confused by that because it's actually kind of a similar scenario to part E a little bit, right? It's like you're exposing people to two different things and asking them what their preference is, right? In both cases. However, in part E, the researchers, as we said, actively put xylitol in some of the milk and didn't put xylitol in other milk, right? And then they gave the milk, both kinds of milk, to the children. Whereas in part F, it's not like the researchers went around and rounded up a bunch of homeless women and made them spend the night in a shelter clinic one night, and then made them spend the night in a government clinic the next night, and then asked them what their preference was. That's not what they did. They just went out and interviewed a bunch of homeless women and asked them what their experiences were, right? So in part F, the researchers were not involved in manipulating the explanatory variable, right? So this is an observational study for sure. Again, the explanatory variable here would be the type of clinic. The response variable would be preference. Okay. So that's that. Hopefully that makes it pretty clear to you the difference between designed experiments and observational studies. Number 2 here. So the second question says, what type of study would allow a researcher to claim cause and effect between explanatory and response variable? This is something that we're actually going to talk about a little bit in a little bit more detail in chapter 4. But for now, I'll say a designed experiment for sure. Designed experiment, because in a designed experiment, the researcher tries to hold all of the variables constant except for the explanatory variable. So then if everything stays the same except for the explanatory variable, and then something happens in response to that, well, so then that's pretty clear evidence that what caused that response variable to change was the explanatory variable that you manipulated. And so that allows you to claim cause and effect. It's because you're holding all of the variables constant. Whereas if you're just performing an observational study, there are lots of things going on. You could have a lot of what are called covariates, right? So you could have a lot of other things going on that are causing some kind of response, and it may not be the explanatory variable that you're looking at that's actually causing a response. Another thing about observational studies is that even if there is a correlation between two variables, that doesn't mean that one of them is causing the other one to happen, because there could be a lurking variable, what's called a lurking variable, right? Like a third variable that's actually causing the other two variables to both change. I'll give you an example of this. So back in the 90s, right, there was this big push for music education in schools. And this is a topic that's near and dear to my heart, because like I was a band nerd all throughout school, and like my dad was a band teacher and stuff, and so so I was heavily involved in music. But the story that was being told at that time was that students who are enrolled in music do better academically. And that was true, right? There was a correlation between being enrolled in music programs and being a high performer academically speaking. However, the mistake that was made was assuming that it was being enrolled in music that caused you to do well academically. But actually that turned out not to be true. What was true is that there was a third variable, and it was, parental involvement and having two parents in the home and all of that stuff, because it turns out that students who had a lot of parental involvement were more likely to both be in music programs and to do better academically. So it's not that being involved in music caused you to be smarter. It's just that if you were involved in music, you were more likely to have really supportive parents who would also support you academically. So being involved in music, it was not a cause for doing well academically, right? They couldn't claim cause and effect. And the reason they couldn't claim cause and effect is because they were just doing observational studies. They didn't do any designed experiments. And as soon as they started doing design experiments, then they figured out pretty quickly that, oh, wait, like being enrolled in music programs is not causing an increase in academic performance, right? They're both response variables to this third kind of lurking variable. Anyway, so design experiments allow us to claim cause and effect. Observational studies do not, right? Observational studies allow us to see correlation, which is valuable, Because if you see a correlation, then that tells you, oh, I should study that thing a little bit more closely to see if there's a cause and effect relationship, right? But you can't just assume from an observational study that one thing is causing the other to happen. And we could get really controversial with this topic because people make this mistake all the time, and there's all sorts of stuff with like social justice and all kinds of things where people tend to assume cause and effect where it's not necessarily the case that there is cause and effect. Um, but anyway, that's all I'll say. If I say any more, I'm going to get myself in trouble. So we'll end it there, and I'll see you in the next section.